Hello, network engineers. I hope you are doing well. Welcome to session 2 of the segment routing series. In the last session, we learned how to configure segment routing. I hope you have tried configuring the same in your lab devices. So let's quickly review the configuration again before we move on to understand how segment routing works. So in order to set up segment routing, we need to enable two knobs, one matrix style wide and another one is segment routing MPLS. Once we enable these two knobs, this will activate the segment routing on the router. Next, we need to configure the prefix index value on loopback 0 interface. So network engineers, here is the quick question. Is it mandatory to define prefix index value only on loopback 0? If your answer is no, then you are absolutely correct. So we need to define the prefix index value on that loopback on which we are going to perform BGP peering, either for VPN v4 address family or L2 VPN VPN address family based on the service which we are going to provide to the customers. So the maximum index value that can be configured is 7,999. So we will soon discuss how this number is determined. So once prefix is configured, router will allocate the label from sRGB. So we need to activate the segment routing first, and then we need to give prefix SID index ID. And once we give the prefix SID index ID, the router will allocate the label from the separate memory block called sRGB. Hey network engineer, let's understand why is a separate label block allocated for segment routing labels. Currently, most networks are deployed with LDP and RSVP for transport label. So we don't want to install segment routing label as soon as we configure it because we don't want to disturb the existing flow. So even when we configure segment routings, the Ceph table will still point towards the dynamic range so that the existing flow will not disturb. So only after configuring the Ceph SR prefer, the Ceph will start installing the label from sRGB. So when a packet hits on pay router, it will perform a lookup in Ceph table and forward the traffic. Okay, so even we configure the segment routing, Ceph table will be pointing towards the dynamic range so that existing flow will not disturb. So in maintenance window, we will configure SR prefer inside the segment routing. Then only Ceph table will start installing the segment routing label and traffic will follow the segment routing instructions. So let's go to whiteboard and understand the segment routing working in detail. So as I told, by default, sRGB would be 16,000 to 23,999 and sRGB base would be 16,000 for each and every router. So let's go to whiteboard and understand the segment routing working in detail. So as we already know, the default range of sRGB will start from 16,000 and ends with 23,999. So by default, sRGB base for each and every router would be 16,000. So let me write it down. Okay, since we are calculating the label for P4 only, loopback 0 of P4, let's call P4 as root router. Okay, now as soon as we configure index ID, fixed index ID, so let me show you in configuration. So for P4 inside loopback 0, I have configured index value 4 and IP address of loopback 0 is 4.4.4.4. So once I configure the index ID, the router will calculate the local label. So the formula to calculate local label would be sRGB base. So the formula to calculate the local label would be sRGB local sRGB base plus the index value. So for loopback 0, the label would be 16,004. So this entry can be viewed by issuing the command show ISI segment routing label table. Okay, so once it will calculate the local label, now P4 will create own LSP and populate the following entry. So for 4.4.4.4, it will put index, which would be 4, and it will carry some flags. So let's track the important one. So the first one would be n. The default value would be 1. So n indicates the tuple of IP, comma index value is unique in segment routing domain. So as I stated earlier, by default, we'll make sure that each router has the unique index ID. And most of the time, we also keep the loopback IP unique on each and every router. So is there any scenario where n could be 0? If your answer is yes, then you are right. So in case of any cast, we can have two router with same loopback and same index ID, which we are going to cover in future lecture. Okay, and let's see the more flags. The another one is P comma E entry. So I'll P comma E, by default it would be 0 comma 0. Okay, P comma E flag indicate either it is explicit null or implicit null. Then it will carry sRGB base. sRGB base is 16,000. So let's see this entries in the lab router. So for P4, let me log in. Let me show you the configuration. Show in router ISIS. You can see index value is 4 for loopback 0. Now it will calculate local label. We can see the local label by using this command, show ISIS segment routing label table. Now you can see for loopback 0, the label 16,004 has been calculated as seen in whiteboard. Now it will create own LSP. So the one which is marked with star is the own LSP, P4 LSP. So let's open it and see the entries. So as seen here, the prefix 4.4.4 is carrying the index value, which is 4, and carrying some flag. So we are tracking n flag, which is 1, indicating the IP and the index value is unique, and then P comma E flag, which we are going to discuss in future transactions. Apart from that, it is carrying the sRGB base as well. The by default value would be 16,000. Okay. Now let's understand further transaction. Now this LSP, the P4 will propagate it to P3 or all the neighbors. So once P3 receive it, first it will calculate the local label. So local label would be the index value of root router LSP, which is 4, plus the own sRGB base, which is 16,000. So local label would be 16,004. Now it will calculate the outgoing label. So in order to calculate outgoing label, it will check few condition. The first condition is whether root router is directly connected to me or not. So from P3 perspective, the root router, which is P4, it is directly connected. Then it will check the flag. So what are my P comma E flag? If P comma E flag are 00, then it will place pop in the outgoing label. So outgoing label pop. So this will be our MPLS forwarding entry on P3. Okay. Now P3 will send root routers LSP P4 and own LSP P3 to P2 router. Now P2 router, P2 will calculate the local label with the same formula, which is own sRGB base plus the index value of root router. And then it will calculate the outgoing label. So to calculate the outgoing label, it will add index value plus it will add sRGB base of neighbor router from which it has received the root router LSP. So P2 has received the root router LSP from P3. So it will add the sRGB base of P3 router. So it would be 16,000. So outgoing label would be 16,004 here also. Okay. And then P2 will forward the root router LSP plus on LSP to P1. So same way, P1 will calculate the local label by adding the index value of root router LSP to the own sRGB base. So it would be 16,004 plus outgoing label by adding index value of root router LSP and it will add it to the sRGB base of neighbor router from which it has received the root router LSP. So P1 has received root router LSP from P2. Hence, in the outgoing label, it will place 16,004. So this would be LFIN entry on each and every router. So let's see all these transactions in lab routers. So P4 we have already shown the local labels being calculated and how LSP is being created. Let's review it. So P4 will send these values to ISI's neighbor. For loopback 0, it will send the index ID, some flags, and sRGB base. Okay. Now P3, upon receiving the LSP of P4, it will calculate the local label first. So in order to calculate local label, it will add P4, which is root router, P4 index ID to the local sRGB base. So this is local sRGB base. So this is the command from which we can see local sRGB range. Okay, and there is one more command on iOS XR to check the sRGB base, which is show MPLS label table detail. Here also you can see the start label, which is our sRGB base. So it will add this value to the index value of P4. So let's see the ISIS LSP for P4. P4 goes. Now in which table it will store the local label first with respect to P for loopback IP? If your answer is ISIS segment routing label table, then you are absolutely correct. Segment routing label table for 4.4.4, it has calculated 16,004 from the LSP. Then what it will check? P3 will check whether P4 is directly connected to me or not. So inside LSP, it will carry each and every interface IP. So if you check the root table for 34.0.0.4, you will see directly connected route. So by this, it will come to know that P4 is directly connected to me. Once it finds that P4 is directly connected to me, then it will check what are the flags, P, E flags. So here P, E flags are 0. Outgoing label, it will put pop. So let me show you the outgoing label. For 16,004, I can see pop here. Okay. Now same way, P3 will forward root routers LSP and own LSP to P2. First, P2 will calculate the local label. So local label would be own sRGB base plus index value of root routers LSP. So own sRGB base is 16,000 and the prefix SID would be calculated from P for LSP. So it would be 4. You can see this P 4 verbose. Index ID is 4. So local label would be 16,004. So it will put that entry in ISI segment routing label table. So for 4.4.4.4, local label 16,004 is calculated. Now P2 will check whether P4 is directly connected to me or not. So P2 is not directly connected to me, then it will calculate the outgoing label. So the formula to calculate outgoing label is the sRGB base of the neighbor router from which I have received P for LSP. So P2 has received P for LSP via P3. So it will put sRGB base of P3, which is 16,000. So let me show you ISI's database for P3 as well. P3 verbose. So it will take 16,000 from P3 LSP and it will add it to index value of P for LSP. Let me show you the P for LSP as well. For verbose, the index value 4. So it will, so in order to calculate outgoing label, it will process two LSP, one from P3 and second one from P4. From P4 it will take the index value. From P3 it will take the sRGB base value, and then it will add it and put it in the outgoing label. So index value here would be 4 and P3 sRGB base would be 16,000. So let me show you the forwarding table. Label 16. Okay, 4. You can see for both it has calculated 16,004. The same way, P1 will receive 2 LSP. Uh, the root router LSP it will receive through P2 and P2 will send on LSP as well. So same way, P1 will receive the P for LSP and get the index ID from it, and then it will process the P2 LSP, fetch the sRGB base of P2, and then it will add it. So on P1 as well, the outgoing and in local label would be 16,004 because we are using default sRGB block. So each and every router is using sRGB base as 16,000. So on P1, let me directly show you the forwarding table. 16,004. Okay, so this is how in segment routing labels would be calculated. So the major difference is, so here labels are not getting exchanged in segment routing directly. Rather, the index value and sRGB base would be exchanged, and each and every router will calculate the label based on that.